Hi everyone, and you are welcome to this lecture, Logical Operators. In this lecture, we are going to learn about a new type of operators that can be used with Boolean numbers, which are logical operators. We are going to learn about logical AND operator. We will learn also about logical OR, logical NOT, and as usual, I will end up this lecture by a quick summary. So let's get started. So what are logical operators? Logical operators are used to combine Boolean values, which we usually get from conditional statements that are written using the comparison operators, the ones that we have learned in the previous lecture. In programming, most often you will face some cases in which you want to check if one or more than conditions are satisfied together, or at least one of these conditions is satisfied. And in order to do so, you are going to use logical operators. Now let's see the details of these operators. For AND and OR, each one of these operators takes two operands, and the operand's data type should be Boolean. So both of the operands should be Boolean, and once the operator is executed, the result is going to be another number, which is also Boolean. For the case of NOT, which is the third operator inside logical operators, it takes only one operand, and this operand should be a number from the type Boolean, and after we execute NOT, the result is going to be another number which is also Boolean. To understand these operators better, usually I like to explain this idea using the electrical circuit. Let's assume we have an electrical circuit in which we have a power supply, two switches, and a bulb. And as you can see here, the two switches are beside each other. We know from physics that to make the bulb on, we have to close both switches, like this. And this is exactly the same of AND operator. In other words, AND operator should take two true values in order to give true. So both A and B should be true to get true. Now let's understand OR by see this electrical circuit. As you can see, I have now the two switches in parallel. From physics also we know that it's enough for one switch to be closed in order to make the bulb on. So if I close A or if I close B, in both cases the bulb will be on. And from here we can understand that if at least one of the operands, A or B, is true, the result of operator OR is going to be true. Now let's move to PyCharm IDE and see some examples in action. First, let me assume that I have two variables. The first one A equal to true, the second one B equal to false. The result is going to be assigned to the variable C, and first of all I'm going to show you the operator AND, so I will say A and B, and I will print C. Let me run this, and as you see here I got false. Why false? Because we see from the electrical circuit that both A and B should be true in order to get true when we use AND. But in this case B is false, so the result of A and B is false. Now if I replace AND by OR and then run, I got true. Why true? Because in case of OR, at least one of the two variables should be true in order to get true, and in this case we have A equal to true. Now let me show you NOT, and as we see NOT need only one operand, and if I say NOT A and run, I will get false. Why this happen? Because NOT will give you the opposite of the value. So if you have true, you will get false, and if you have false, you will get true. In this case, A is true, so NOT A will be false. If I put here B, which is false, and I say NOT B, I will get, as you see here, true. One more idea I want to highlight in this lecture, as we see that these operators return Boolean values, so we can use more than one operators in the same expression to build a more complex expression. So for example, I can say NOT and then parentheses A and B. We know that A and B will give me false, and false it's a Boolean value, so I can use in this case NOT, and if I print I will get true. Why true? Because A and B is false, not false is true. The last idea that I want to share with you in this lecture is a quick reminder about comparison operators that we have learned about in a previous lecture. If you remember, comparison operators are operators that usually give me true or false according to the comparison result. So for example, if I have A equal to 10, P equal to 20, C equal to 30, and then I say D equal to A bigger than B, and I will put parentheses, or C not equal to B, and then I print D. Why I am able to put OR here? It's very simple, because these comparison operators here will give me true or false values. And as I know that logical operator OR take two operands which are Boolean. So using logical operators and comparison operators, I'm able to build more complex expressions in Python. Let me run this. I will get true. Why true? Because A is bigger than B. Let me check. No, A is not bigger than B. So this will give me false. C not equal to B. Yes, C not equal to B. So this will give me true. False or true, it's true. And the final result is true. And that's all for this code session. Now let me summarize what we have learned in this lecture. First of all, logical operators have been defined as operators used to combine conditional statements, which usually give me true or false values. We see and or, and as we see, these operators take two operands, and these operands should be numbers, exactly Boolean, and the final result after this operator is executed is number. We see also not, and we see that not takes only one operand, and this operand should be a number, which is Boolean in this case, and the result also a Boolean number. Please refer to the file Logical Operators Appendix, in which you will find all of these operators have been summarized. Also refer to the file Logical Operators Challenges, in which you will find some exercises to practice what you have learned in this lecture. Thank you very much for your time, and if you are available, join me in the next lecture.